Alright, so it's time to finish our notes on transformations and finally put all of our parameters together. So this is the note, transformations, putting it all together. So now we've talked about all four parameters, so make sure you get this down. You might need to pause the video. So A indicates a vertical stretch or compression or a vertical reflection. K indicates a horizontal stretch or compression or a horizontal reflection. D indicates a translation left or right, and C indicates a translation up or down. Some little trick I like to do is what's inside the function here, the H, the K, and the D, those are horizontal changes. See how it makes an H? And then here, I didn't have enough space here, so you could do the H above. Here, the A and the C create a V, and those are vertical changes. So the numbers that are outside the function, A and C, so either being multiplied outside the function or added outside the function, those are vertical changes. And then the parameters within the function, so with the x value, those are horizontal changes. So notice that in order to determine the values of k and d, as seen above, you have to factor out k. Notice that k is actually factored out. It says k bracket x minus d. So in order to see the d properly, you have to factor out k first. So I just have a few examples set up for you. So for example, here you might make the mistake that there is a horizontal compression by a third, and then you might go to the right 9. Well, the third is right because you factor out the 3, but however, when you factor out that 3, you see that the d value is actually 3 as well, and you're only going right 3. So the 9 would be incorrect there. You have to factor out the 3 in order to see the horizontal translation. So here, again, you might say, oh, it's a horizontal stretch by 2, and I go left 1. That would not be correct. Okay, you have to factor out the 1/2, and then it would be x plus 2. Okay, a lot of people accidentally write 1/2 there, but think about it. If you were to expand it back, a half times a half would be a quarter, and you need it to expand back to 1. So what expands back to 1 when multiplied by a half? Well, it's 2. So always just check, do a quick check. Half times 2 is 1, and that's the appropriate way to factor that out. And also be careful for negatives. So in this example, we factor out -2, and we're left with x minus 4. Okay, so this is actually right 4, whereas if you hadn't done that, you would have made the mistake and gone left 8. So parameters affect the function both obviously vertically and horizontally, so it's helpful to separate the vertical changes from the horizontal. So the y values are affected by a and c, again the values outside of the function. So if x, y is on the function, then the point x, comma, a, y plus c is on the function a times f at x plus c. Okay, so basically all the y values are first multiplied by a, and then you just add c. That's how you go from one to the other. So for example, if we have x squared as our first function, so we might have the point 1, 1, also the point 2, 4, and we know that our new function here is negative 3x squared minus 1. Well, first we can identify that a is equal to -3 and c is equal to -1. So all of these functions are going to, all these y values, are going to be multiplied by -3, and then you subtract 1, and that's how you come up with the new point. So the point 1, 1, the x value isn't affected because we only have an a value and a c value, so it stays the same. But then our y value of 1 is multiplied by -3, and then you subtract 1. So that gives you the coordinate 1, -4. So that y value has been stretched vertically by 3 flip down to -3, and then down one more to -4. Okay, 2, 4 are the same thing. Your x value stays the same, but then 4 is multiplied by -3, and then you subtract 1. So you get 2, -13. So you can think about it. That value of 4 has been vertically reflected to -4, then stretched by 3 to -12, and then translated 1 down to -13. So therefore, A and C affect the range of a function. It can affect if it's all above a certain number or all below a certain number. So the above or below depends on if A is positive or negative, and the certain number depends on if C is a value. So then like a vertex or something like that has been moved up or down. Okay? So we are left with K and D, so those affect the x values. So if xy is on the function of f at x, then x divided by k plus d comma y is on the function f at k bracket x minus d. Okay, so this is where there's no a or c value. We're just looking at k and d, so the horizontal changes. Okay, so you're dividing all of your x values by k, and that's because a 3 would mean a compression of a third, and a half would mean a stretch of 2, so it's kind of opposite what they mean, so that's why you divide. And then you're adding d, but make sure you recognize that d is normally negative d. So in this case where you have a minus, it will be a 4 when we factor it out, that's actually your d value is 4. So before we do this, we have to factor out k. Anytime k is involved, you need to see if it has in fact been factored out yet or not. So we can identify our k value is 2 and our d value is 4. Again, it's 4, not -4, because the standard form is x minus d. Okay? So we could transform a point, for instance, 1, 1. Okay? So all of our k values are x values are going to be divided by 2, and then we add 4. So 1 will be divided by 2, and then we have to add 4, and y will stay the same. So that's going to give us 4.5, comma 1. So again, this point, the 1 value has been has been compressed by 2, so it's half of where it used to be. So instead of at 1, it's now at a half, and then it's translated to the right 4. So that's how you get 4.5. Okay, what about the coordinate 2, comma a half? Okay, that's a point that's on this original function 1 over x. So again, the x value is going to be divided by k, so we have 2 divided by 2, and then we have to we have to add 4, and our y value will stay the same. Okay, so that gives us 5, comma a half. So think about it. This value of 2 has been compressed by a half, so it's at 1, and then translated to the right 4 to get to 5. So k and d affect the domain of the function. So that was separating it into just the vertical, just the y values, just the x values. Now we're going to get to doing both of them together. So if you have the point xy, it turns into x over k plus d, comma a y plus c. Okay, and this is assuming a function like we had at the beginning. Okay, that's where those parameters are coming from. Okay, just a little note, make sure you follow BEDMAS. Okay, so make sure you do the multiplication or division before you do any addition or subtraction. So that means do the reflections and the stretches and compressions before you do any movement to the left or right, so any translations. Okay, so that's basically the summary of putting it all together. So now we're going to do 3 examples where we're applying all the parameters to a parent function. So we'll start with the parent function of root x. So you can start filling out that table of values for root x, and drawing the parent function, graphing the parent function. Okay. All right, so here we go. So it wants us to write the major transform points, then the domain and the range, and then sketch the transformed function. So this is root x, so I always do these key points. Start with 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. Those are all nice integer coordinates, and then you draw it, and then that's your base, okay? I usually start with like a pencil or a plain color, and then do my transformation in a different color. I don't know, it just helps me. So let's first identify what our parameters are, okay? So we can rewrite this. Notice this is in function form with the f, so it actually hasn't been written as a function yet. So let's do that. So g at x is going to be, so 2 times f at x, so 2, equals root, and then f at x minus 1, so the x minus 1 is under the square root, and then subtract 4 is on the outside. So that means our a value is 2, our d value is minus 1, and our c value is minus 4. So this means a vertical stretch by 2, a left 1, and down 1. Okay, so let's just consider our x values first. So remember, anything that is inside the function affects the x values. So all the x values are just going to be subtracted by 1. Okay, and that's how we're going to come up with all the x values. So you just look at your original x values and then subtract 1 from all of them. Minus 1, 0, 3, 8, 15. Okay? And then we change our y values. So we have 2 and negative 4. So all the y values will be multiplied by 2, and then we subtract 4. So 2 times 0 minus 4 is negative 4. 2 times 1 is 2. 2 minus 4 is negative 2. 2 times 2 is 4. 4 minus 4 is 0. Okay, and you continue that way, so you get 2 and 4. And so there you have it. So because we started with these nice integer values, and we didn't have any weird fractions up here, we ended with nice integer values. So now you can just plot these points, and there you have it, your transform function. So negative 1 minus 4, 0, negative 2, 3, 0, 8, 2, and 15, 4. Oops, swap over here. So there you have it. You start here. Oh, no, you just start there. There's something below that, actually. Start here. And do your best to make a gradual curve through these points. Okay, this is g at x. There you go. All right. So again, you could do it on the graph. So if you took each point, you could stretch it by 2, so make it twice as high. So instead of 1 high, it's 2 high now. And then just move it left 1 and down 4. So you can do it visually as well. So again, take this point, stretch it twice as high, left 1, and then down 4. Okay, so that's what we've done here. So your new domain then, okay, now think about it. Originally, our domain was x, such that x is greater than or equal to 0, but now it's been moved to the left, okay? So remember, domain is affected by k and d values, so our x is now greater than or equal to negative 1 because we've moved everything to the left 1. And our range, normally, with a square root function, is greater than or equal to 0, but we've moved this guy down 4, so now this range will be greater than or equal to negative 4. Okay, and it's still above, it's greater than or equal to, because we haven't reflected anything down. So take some time to examine that. Make sure you understand it. Okay, because notice that one didn't have a k value. So anytime there's no k value, I'll be honest, things are quite a bit simpler without a k value. It's the k value that I find the most difficult. So just keep that in mind when you do come across k values like we are about to. Okay, so here we have our original function is the reciprocal function. So I came up with these initial values. So the x values of -2, -1, and -1/2, then their corresponding y values. And then I stuck in the vertical asymptote there, so you are able to draw that and show how that's been moved. Then I have x values of 1/2, 1, and 2, and their corresponding y values. And then I also threw in the horizontal asymptote because that will move up and down along with the c value. So this function then, see it's negative f. So our new function then, we have a negative on the outside. F at, so we have 2, and then I'm going to factor out the k right away. So again, this is inside the function, so that means it's in the denominator. And then the +3 is on the outside like this. Okay, so our a value is -1.